Hello and welcome to our next section, the transitive and reflexive property. This is going to be the last in terms of properties. This is going to be the last set of notes for it, but we will get into two-column proofs in the next video. So just keep that in mind. The transitive and reflexive property are used in GCRs, and we will use them for two-column proofs a lot. So just keep that with an open mind. It may seem very, very easy at first, and that's okay. Don't take it, don't take it for granted. So hopefully you pause the video already for the index or the table of contexts, and then get this title down and let's jump into it. So the transitive property, and you might have seen or heard this at some point in your math education. The transitive property simply states if A is equal to B and B is equal to C, then A is equal to C. So if you really think about this with numbers, if let's say A is equal to 4, that means B is equal to 4. That transposes to this equation. 4 is equal to C, or B is equal to C, which means C is also equal to 4. That means A is equal to C. 4 is equal to 4. So just numerically, that should hopefully make sense. Geometrically, we work with angles and segments. And let's draw a quick diagram just to illustrate this. So let's draw a triangle. Okay, let's draw let's make this a little bit wider. So and then we'll also draw some segments from the vertex straight down. Okay, we're gonna put some letters here. Let's start A for the vertex, B, C, D, E, and F. We don't need that there anymore. Okay, and then we could actually even put some angle numbers here. Let's call this angle 1, 2, 3, and 4. And I think that would be enough to get through this. Let's see if we might have to put some other angle numbers, but I think this is fine. So the transitive property. First example, let's say our given is angle 1 is going to be congruent to angle 2. Let's also say angle 3 is going to be congruent to angle 2. What can we ultimately conclude? Well, so let's put conclusion here in the reason. If I say angle 1 is congruent to 2, and 3 is congruent to 2 as well, so 2 is congruent to 3, we could ultimately conclude that 1 is congruent to 3. So this is kind of like connecting the dots. 1 goes to 2, 2 transfers over, 2 goes to 3, and then ultimately we get some kind of linearity where it's kind of like connecting the dots. Where do you start and where do you end is kind of like how I like to look at it. So we could ultimately say angle 1 is going to be congruent to angle 3. And this is an if-then, or you could technically use the transitive property, but the if-then would read, if two angles are congruent, and if you notice, they're congruent to both of them are congruent to angle 2. So the same angle to the same angle, then the two angles are congruent. Now you could also use this for segments. For instance, if we're working with segments, you'll see that in a second, but segments could replace angles, just like how we had it. So we have multiple versions of this, and we'll get into that in a second. Now the reason could also change. We could also call this the transitive property, and I'd much rather you say this, the transitive property for same angle. So just like how we have it here, we specify is it the same angle or congruent angles. Here it's going to be the same angle because they are literally equal to the same angle. 1 is congruent to 2, 3 is also congruent to 2. That's their connecting piece. Okay? So there it is. Just no. Actually, no. Let's do that. Let's do another one. Let's say, for instance, example 2. Well, we didn't put a 1 here, but it's okay. Example 2. Given, let's say BC is going to be congruent to CD. We could also given EF is going to be congruent to BC. What can we, and let's do one more. Let's do DE is going to be congruent to BC. EF, let's actually go EF. So, starting here, BC is congruent to CD. So I'm going to put 2 tick markers there. We also have BC congruent to EF. So there should be the same tick marker. And last but not least, EF is congruent to DE. What can we ultimately conclude? So it's remember this is like connecting the dots. BC jumps here. Oh no, BC to CD. Actually, starting with CD, we go to BC. So this one's a little bit weird because BC travels to here. BC connects to, or is congruent to EF. EF is connected to this EF, which connects and transfers its congruency to DE. The other way to think about this is a pairing game. We see BC here twice, we see EF here twice, and what's left out? That will kind of be our conclusion, okay? This is nice for the transitive property for that reason. And we see here our conclusion is CD is going to be congruent to DE. Now, what's CD congruent to? CD is congruent to BC. What is DE congruent to? DE is congruent to EF. Are those the same angle or same segment? No. So the reason here is different. This is still the transitive property because that information is transferring from one segment to another. So this is still the transitive property. But it is for congruent segments. Okay? Now, just like how we have before, the transitive property, you would have either same segment, congruent segments, same angle, or congruent angles. Okay? So those are your options for the transitive property. So when you write the reason, you have to be specific. If you're going to use a property version of it, you have to use the specific reason. Okay? Now, we also have the reflexive property. And this happens, and this is going to sound weird at first, in geometry anyway, it is when an angle or segment is congruent to itself. Now, that sounds really, really strange, and you're going to see what I mean because there's going to either be a shared angle or a shared side. So, let's draw a diagram. First one, off to the right, and we're going to draw a rectangle with one diagonal, and let's call this B, E, A, R. Now, if you notice, there are 2 triangles here, right? The diagonal makes 2 triangles. So the given is going to be weird. It's going to just say diagram as given. Diagram shown. Okay? The conclusion might be blank, and the reason might be actually provided for you by the reflexive property. So this is a side that is congruent to itself in this particular case. So reflexive property. And if you notice, we have, like I said, we have 2 triangles here. So I'm going to highlight this one. And then I'm going to also highlight this one. And if you notice, they share this side in the middle. So this side, I'm going to mark with either an S or a backward S to show reflection. This is your reflexive property kicking in. And it's very useful whenever in the chapters to come to use that symbol. Reflexive property is being used here. So in this particular case, the blue has BA, right? Which no matter what will be equal to or congruent to the red triangle's BA. It's kind of like when you cut a sandwich, from corner to corner. You get two different pieces, but this length, if it was like, let's say 10 centimeters, will be the same on the other side or the other triangle as well, 10 centimeters. So keep that in. I like to use that analogy like a grilled cheese. It's very, very helpful, very useful, and it depicts this situation very, very well. Now, the other one I want you to be able to hopefully visualize is when you have congruent angles. This one's a little bit harder to see. So notice here we have one triangle. And then I'm going to draw another segment from the bottom right corner, and we just created another. And if you notice, there is an angle here that actually overlaps between the two triangles. It is the one at the very top of this vertex. So if I put some angles here, let's say S, E, L, A, G, U, just random letters, are given, could read diagram or diagram shown. Our conclusion would be, we could say, in this particular case, we have a red triangle and blue triangle, so we could say angle S, and notice I'm doing it in red, and I probably should have done it above. It's going to be congruent to angle S. So if I separated these two triangles, it would have that angle, this angle, if this was like 40 degrees, it would be 40 degrees in both, no matter what, okay? You could draw them separately if that helps, or you, like for instance, the blue one will kind of look like this. The red one would kind of look like this if you separated them. And this angle here at the vertex would be congruent to each other, okay? So the reason here would be the reflexive property. When an angle is congruent to another angle or itself. If you separate them, it makes a lot more sense, kind of like how we separate this, like our grilled cheese gets cut into half, except here we have an overlapping angle. So hopefully this makes sense. If not, we'll definitely get some more practice with it. We have a ton of use for it, especially in our triangles chapter. So keep these in your mind moving forward. And if you do have any questions, please ask them, and I will see you in the next one. Bye.